Alright, welcome back. This will be the last video of the year. This is College Algebra. We'll be solving systems of 3 equations and 3 unknowns. We'll be using this system called Gaussian elimination, named after a mathematician in the previous, I think in the 17th century, but I'm not sure. Anyways, let's go to solving equations. We're looking for solved equations of this type. For your homework, so actually for the final, this system will have a solution, but just so you know for next time, when you take the next class, inconsistent means the same thing it meant last time. There are no solutions. Dependent mean there are an infinite number of solutions. But the ones that you will get here will always have one solution. We don't have time to go over all of these, so at least know how to solve the ones that have one solution. And so then you don't have to worry about the rest of the directions. I'm just going to ask you to solve the equation on your final. So, how do we do this? Well, we did this in class on Wednesday, and the 3 steps that I gave in class that day were the following. First of all, first step, we're going to choose a variable to eliminate any one of these any of these variables. And we're going to choose an equation that will help us eliminate this variable. And so I want to focus on this first. So if I want to choose a variable, so choose a variable here, that means I have to choose the x, the y, or the z. And it really doesn't matter which one, but because of what you're going to learn in your next math class, I'm going to choose the x. Because when you do matrices in your next math class, they usually choose this variable to solve for first. And so we'll use this one. So my choice for this will actually be the following. So I'm going to choose a variable, I'm choosing x. And then you have to choose one of the equations. So there are 3 equations here. This is equation 1, this is equation 2, and this is equation 3. I always choose the equation that has the least number of coefficients. So here the coefficient is 2, 3, 2. Here the coefficients are 3, -2, and -4. Well, I'm going to choose the one that has coefficients of either 1 and 1 or a coefficient of -1. So I'm choosing the first. So the one that I get to choose will actually be this first one. So I choose this equation. So that's how you start. Just choose a variable, choose an equation. Try to choose the x, and then try to choose the first equation usually. Well, choose not the first equation, but the equation that has the least number of coefficients. All right, now the goal here now is to eliminate the chosen variable in the other 2 equations. So these are the other 2 equations right here that I'm highlighting. So we want to eliminate the x's, these 2 x's in the other equations, and it says by adding appropriate multiples of the chosen equation. And so here in step 2, we actually have to do 2 things. So for example, I'm going to write equation 2 first. So this is the first thing I do. Here's equation 2, 2x plus 3y plus 2z equals 3. But I need to add an appropriate multiple of the chosen equation. So I need to add an appropriate multiple of the first equation. So what I'm going to do is I'm going to take equation 1, but I'm going to multiply it. Actually, let me erase that. I didn't want to do that. Let's take equation 1, but I'm going to multiply it by -2. So -2 times equation 1. And if I multiply -2 times equation 1, so here, -2 times x is -2x. -2 times y is -2y. -2 times -z is +2z. And then -2 times 4 is -8. And so I end up with this. And then the way we eliminate is we go ahead and add down. And so the 2x and the -2x cancel, and I'm left with 0. 3y minus 2y is just y. 3y minus 2y. 2z plus 2z is 4z. And then 3 minus 8 is -5. And so this is one of the new equations. I should create 2 new equations. Well, here I am creating the new one. I'm going to call this 2 prime. Okay, and so we'll do this again. And if you want, I would pause the video right now and maybe take this third equation and add a special multiple of the first one and see if you can get rid of the 3x. Okay, so I'm going to zoom out a little bit so I can have a little bit more room. So now what I like to be able to do is now, if you came back, if you just finished pausing, I would like to take a multiple of the third equation. So I'm gonna take the third equation. Sorry, not a multiple. I'm gonna solve for the third equation. So I'm gonna take the third equation here, which is 3x minus 2y minus 4z equals -1. And I want to take a multiple of the first equation to get rid of the 3x, And so to me, the most appropriate number to multiply the first equation by is -3. So -3 times equation 1. So if I take -3 times x here, I get -3x. If I take -3 times y here, I get -3y. If I take -3 times -z, I get +3z. And if I take -3 times 4, I get -12. And again, I go ahead and add these. And so this time I'll get that 3z minus 3x is 0, so we won't write that down, we'll just cross it out. And then we get -2y minus 3y, so I get -5y. -4z plus 3z is -z. And then -1 and -12 is -13. And so here's my next equation, the other one of the two equations, and so I'm going to call this 3 prime. Okay, so now we're ready to do step 3. And so in step 3 it says we're going to use the two new equations to solve. So the two new equations are this one, y plus 4z equals -5, and the one with 3 prime, -5 minus z equals -13. And so in step 3, I'm going to write my two equations. So 2 prime, which is y plus 4z equals -5, and 3 prime, which is -5, y minus z equals -13. And we basically repeat the process. What we're going to do in this one is we're going to, oops, let me move this all up. So I'm going to use the two new equations to solve, and so, sorry, I'm trying to move everything up here. I'm going to use these two new equations to solve, and I'm going to repeat the same process. I'm going to choose an equation. I'm going to choose this one. I'm going to choose the y as my variable, and I'm going to eliminate this 5y right here by multiplying this by 5. And so I'm actually going to go ahead and do that. I'm going to say, let's take 5 times equation 2 prime, and what I'm going to get is I'm going to multiply this y by 5, so I get 5y. I'm going to multiply this 4z plus 5, so I get 20z. And then I'm going to multiply this -5 by 5, and I get -25. And by the way, I made a mistake here. This is -13. Okay. And so now, we go ahead and add these two. We get 0, so we're not going to write those down. We'll just cross them out. And then I'll go ahead and take these two, -z plus 20z, that's 19z. So I'll go ahead and write 19. And then the last part, -13 minus 25, that's -38. Oh, but you know how to solve these. You see, you know that all you have to do is divide by 19 on both sides, and then you get that z equals -2. So there's this part of the solution. Now remember in class what we mentioned was that we were looking, and I forgot to say this, we're looking for 3 numbers that solve these 3 equations, all 3 of them. And so, sorry about the mess here, but that's sort of the goal. And so now I need to find what x is, what y is, sorry. And so to find what y is, what I'm going to do is I'm going to use one of the two new equations. I'm going to use one of these two to find out what y is. And I think this one's the easiest one here. So to find the next equation, so to find y, plug in z equals -2 into 2 prime. And so what I'll get is the following. I'll get y plus 4 times something equals -5, and I'm plugging in the -2, and so I get y minus 8 equals -5. And so when I add 8 to both sides, I'm going to get that y equals 3. And so there's another solution. Very nice, we got 2. So now I need to find x, that's the last thing. And so here, what I'm going to use is the first equation. The first equation is x plus y minus z equals 4. X plus y minus z equals 4. So let me write that down. So to find x, plug in z equals -2 and y equals 3 into 1. And 1 is x plus y minus z. Equals 4. And I'm going to check again just to make sure that I wrote it down right. Sorry. So x plus y minus z equals 4. Good. So far, so good. All right. And so now I'm going to go ahead and do this. The x, we don't know, so I write x. The y is 3, so I would put plus 3. And then minus and -2, so minus and -2 equals 4. And let me move all of these things up. Okay, and so I'm left with x plus 3 minus minus 2 is really 3 plus 2, so x plus 5 equals 4. And so when I subtract 5, I get x equals -1. All right, and so now we can check. And so we check all equations. For example, in equation 1, you can write, notice that you have -1 plus 3 minus and minus 2 is supposed to be equal to 4. And sure enough, -1 plus 3 is 2, and 2 plus 2 is 4, so that one checks. And you should actually check all of them. So equation 2 is 2 times -1 plus 3 times 3 plus 2 times -2. And we're supposed to get 3. And so again, we check 2 times -1 is -2 plus 9 minus 4 equals 3. Order of operations says do these first, so 7 minus 4 should be equal to 3, and that's true because -2 plus 9 is 7. And finally, the third equation, this third one down over here, oops, this third one, oh no, sorry guys. This third one over here, this third one, I can't do it. Sorry, you guys. But anyways, the third equation, all we have to do is then say, okay, well, 3 times -1 minus 2 times 3 minus 4 times -2 is equal to -1. And sure enough, notice that I get -3 plus 6 plus 8. Three x minus 2y minus 4z equals -1. Oh, that's my mistake. I see it. This is supposed to be a negative, so negative 3 minus 6 plus 8 is supposed to be -1. And then again, order of operations says this first, and -9 plus 8 really is -1. And so we checked them all out. And so this is how you solve this equation. We got our solution. And so the solution then is 2 ways to write it. One is to just say x equals -1, y equals 3, and z equals -2. If you attempt to try some problems in the book, then they might write the answer like this. So, or -1, 3, -2. All right. Make sure to know how to do this problem. There will be a problem like this on your final. Other than that, good luck with all your finals preparations and all your finals, and I'll see you guys on Friday.